Hi everyone, I hope you're having a great day. It's going to get even better because we're going to talk about molar mass. So let's begin with the definition. Here's your definition. Molar mass. An element's molar mass is the quantity in grams equivalent to its atomic weight. So atomic weight, jog your memory on this. The atomic weight is the weighted average of all of the isotopes for one element. And when you bring those weighted averages together, it's based on their mass and the abundance, their relative abundance that they occur in nature. Take all of those weighted averages and you get one number on the periodic table, and that is the molar mass. Now, when you and I had done the calculations, I told you that it was atomic mass units. Well, that number actually represents two things. It's going to be the atomic mass unit if we're looking down at the atomic level, and it's also going to be if we look at the mass level, the gram level. It's the same number. It's the same number. Let me show you on the periodic table. Now, I know that you can't see all of these numbers. Sorry about that. Here we go. There we are. Sorry about that. I know that you can't see all these numbers. I actually have a little periodic table here that I can look at too. I want to show you though where you find it on your periodic table. You can see the whole number. That's the atomic number. That's going to be the number of protons. And then the number that's going to be decimals, usually underneath the element symbol, that's the molar mass. Okay, and remember we can also say AMU. We use it most commonly though in the molar mass section, in that ideology and vein. So let's look at carbon. Carbon right here, its molar mass is 12.011. 12.011. So what does that mean? That means if I have 1 mole of carbon, okay, and this is going to be, remember, the weighted average of all the isotopes. If I have 1 mole of carbon, I've got a pile of carbon, guess what? It's going to weigh 12.011 grams. There's that many grams of carbon in 1 mole of carbon. Very cool. Let's do another one. Let's take silver. That's kind of a fun one. So silver's atomic mass is 107.87. So 107.87. What that means is if I take exactly 107.87 grams, so I have this on the scale, I have this gold weighing, and I read the scale and it says 107.87 grams, that means I have exactly 1 mole of gold. Now extend this back to what a mole means. That means I have 6.022 times 10 to the 23 atoms. Okay, so think about this. Let's put this all together. I have 107.87 grams sitting on the scale. That's 1 mole, which means if I counted every single little atom, there would be 6.022 times 10 to the 23 silver atoms on that scale, which weighs 107.87, which is 1 mole, because it's the 6.022 times 10 to the 23. It all comes together. It all comes together. Let's do another one. Let's take lithium. Lithium is 6.94. Now the unit, I've kind of danced around this, but now I'm going to give it to you officially. The unit for molar mass is grams per mole. The atomic number, atomic weight that you see, that is always the grams. That's the mass if you have 1 mole of that substance, 1 mole of that substance. So if I have 6.94 grams of lithium, that means on this scale that I'm weighing that there's 6.022 times 10 to the 23 atoms on that scale. They weigh the 6.94 and that's classified as 1 mole. Pretty neat. So when you look at the molar mass, that weighted average, okay, the atomic weight, molar mass, same thing. When you look at that number on the periodic table, right away, you have this wealth of information. You have this unit. That number tells you the mass when you have 1 mole, 6.022 times 10 to the 23, of that particular element. Now, we can do this for not only elements, but also compounds. All you have to do is add all of the elements molar masses together for that compound, and you just found the molar mass for the compound. I will actually do a separate video with those calculations. Now, I want to give you a visual of some of this. Sulfur, here's sulfur right here. Its molar mass is 32.07. Let me make sure. 32.07. Just so you know, I've also seen 06. It depends on the periodic table on sulfur. Here it is. There, right there. That is 1 mole of sulfur. So if I were to empty all of this sulfur onto a scale, how much would it weigh? 1 mole of sulfur weighs 32.06 because the periodic table tells me. Now, if I extended it and I said, well, how many sulfur atoms are in here? You've got it. It's 1 mole, so there's 6.02 times 22 times 10 to the 23 sulfur atoms. Let's do another one. Let's see here. Ooh, this is a compound. One of my favorites. This is copper sulfate pentahydrate. Isn't that a pretty blue? Love it. This is 1 mole of this compound, of a hydrate. That tells me I have of this compound 6.022 times 10 to the 23 compounds inside of this, and that's 1 mole. A couple more. This is pretty close. Is 0.97 moles of nickel. Kind of cool. A nickel crucible. Isn't that fun? Kind of fun. Let's just pretend it's 1 mole. So I would have 6.022 times 10 to the 23 atoms of nickel. But like, if this is 1 mole, how much does it weigh? No worries. I look at the periodic table. Here is nickel right there, and that would weigh 58.69. 58.69 grams right there if I put it on the scale, assuming it's 1 mole. Another one. Here is 1 mole of salt, table salt, sodium chloride. That's what that looks like. So 6.022 times 10 to the 23. And I will teach you how to figure out the mass on this. Okay, teaser. All you do is add the 1 chlorine, 35.45, and the 1 sodium, 22.99. Add that together and you have the mass when you've got 1 mole of the salt. Let's do 2 more really quick. Here is 1 mole of copper. 1 mole of copper. So put this on the scale. I already can tell you what it's going to weigh. When I put this 1 mole of copper on the scale, it's going to weigh 63.54 grams. I know that because 1 mole is the mass on the periodic table, the molar mass. Last one, aluminum. Just wanted to show you. There's 1 mole of aluminum. So I've got 6.022 times 10 to the 23 atoms, and I can tell you how much it weighs right now from the molar mass. There's aluminum atomic number 13. It weighs 26.98 grams. 26.98 grams. Okay, there's molar mass. Thank you.